Assalamu alaikum dear students. Today we are going to discuss the unit relations and functions. Firstly we will discuss the relations and later we will discuss the functions. In class 11th you studied about relations. Now let's have a look what you studied in class 11th. Now if we have two sets, set A and set B, you know that any subset of A cross B, where A cross B is the Cartesian product of two sets, that is set of all ordered pairs whose first entry is from A and second from B. Now any subset of A cross B is simply called as the relation. You know it. Now the set of first entries is called as the range domain, while a set of second entries of ordered pairs in any subset of A cross B is called as the range of relation. Now you know that if we have two sets, set A and set B, where A has n elements, B has m elements, then Cartesian product has n m elements, that is product of these two numbers. So the total number of subsets of this set, because A cross B is in turn a set, is 2 raised to power mn. So this means that there are from A to B there are 2 raised to power n m relations possible from A to B when cardinality of A is n and cardinality of B is m. Like if we consider A equals to 1 2, B equals to 3, so A cross B is 1 3 and 2 3. Number of elements in A cross B is 2, so this means that number of subsets of A cross B is 2 raised to power 2, because 2 raised to power number of elements, which is 4. So this means that there are 4 relations from A to B. Now if we consider the subsets of this A cross B as R1 is 1 3, this is a subset, R2 is 2 3, this is a subset, R3 the set itself, this is also a subset, and the empty set R4. So these are the 4 subsets of this A cross B. Hence all these 4 subsets are the relations from A to B. Now here R1 and R2 are the proper subsets of A cross B, so these are called as the proper relations. While as this R3, when we consider this as a subset and in turn this as a relation, this is called as the universal relation, because every set is a subset of itself. So this is the universal relation. Similarly, if we consider R4 as subset, which is a trivial subset, this is called as the empty relation. You also know that when if we have the set, we can represent in two ways. One is the set builder form, second one is the roster form. Likewise, sets we can also represent the relations in different forms. One is the set builder form, second one is roster form or tabular form, and the third one is visual representation. You know it. Like if we have two sets, set A and set B, and we consider 1 3 1 5 1 7 as the subset of A cross B. This means that this subset, this 1 3 1 5 1 set, is the relation from A to B, because it connects or it relates the elements of A with the elements of B. Now here in this representation we have each and every element of this set. So this is the tabular form or the roster form. We can also represent this set in the set builder form as it is a set of ordered pairs. Those ordered pairs x y, while x is 1 because everywhere first entry is 1 1 1, so x is 1 and y is 1 plus 2n, where n is 1 2 3, or y is x plus 2n where n is 1 2 3, because when x is 1, when x is n, y is 1, when x is 2, when n is 2, y is 5, when n is 3, y is 7. So this means that this is the tabular and the set builder form of this relation. Similarly, we can have the visual representation, and in visual representation we write set A here, elements and here the set B elements, but through this relation 1 is related with 3 because it contains ordered pair 1 3 here. It contains here the ordered pair 1 3, so we can connect 1 with 3 as this. Similarly, it contains 1 5, so here we have 1 5 and 1 7 is like this. So this is another way to represent a relation. If we consider another subset R3 as A cross B, or R3 as 1 3 2 3, so this means that the first set is AB, which is 1 2, and the second is 3, so 1 is related with 3, 2 is related with 3. So this is the visual representation of this R3 when we consider whole as a subset of A cross B. So from this we conclude that the universal relation here, universal relation is that relation in which every element of A, means all elements of A, are related with each and every element of B. And the null relation is that relation where none element of A is related with B. So this is the empty relation. So relation is simply subset of A cross B. From if we have the relation from A to B, then we say that R is subset of A cross B. Here if A belongs to AB belongs to this ordered pair belongs to this relation, we say that A is related with B, means element of first set is related with the element of second under this relation, under this subset R. Here this for this ordered pair AB, first set belongs to set A, second belongs to B, that is B belongs to B. Now if we consider the particular case which we have to discuss or which we have to study in this chapter, if we have A equals to B, that is first set equals to the second set, then if we have the ordered pair AB which belongs to A cross B, this means that first set belongs to A, first element belongs to A, second also belongs to A. So this means that we have to consider the ordered pairs in which we have to take first entry from A and the second from A also. Like if we have A equals to 1 2, this means that A cross A is 1 1 1 2 2 1 2 2. So this is the Cartesian product of the set with itself. Now if we consider any subset of this A cross A, then that is a relation from A to A because it contains the elements of A with itself. This relation is simply called as the relation on A, or we call as the relation on set. Here we have to discuss the relation on the set, not the relation from set to another set. So this means that we have to discuss here the relation on simply set. Now, what is relation on set? It is simply a subset of A cross A if we consider A as the set. Now the types of this relation, or first one is empty relation. Empty relation is that relation through which none element of A is related to itself, or none elements of A are related to the elements of A itself. That is simply called as the null relation, void relation, or empty relation. Now the second one is universal relation. If each element of A is related with each and every element of A, then the relation is called as the universal relation or the improper relation, because this is possible only when we consider A cross A as the subset of A cross A, because every set is the subset of itself. When we consider A cross A as the subset of itself, then that relation is simply called as the universal relation. Here sometimes this universal relation and this empty relation or the void relation, these relations are called as the trivial relation, because on the basis of triviality we can say that these two relations are this trivial relation. Now if we have let me consider, let A equals to set of all males of a particular area, and we consider R as a subset of A cross B as AB, while A is male, B is male of this set, means of this particular area. A is the sister of B, A is the sister of B. Then clearly this R1 is empty set, or the empty relation because it does not contain any ordered pair. Because there are only males, we consider this A as the set of all males of a particular society. So this means that there does not exist this sister relation between any two males. So this means that this R1 is empty relation because there is no female in this society or in this area. So R1 is here the empty relation. Now, if we consider R2 to be set up all those ordered pairs, that is, set up all those males, A is the male of this A, B is the male of this particular area which is represented by set A, then difference of the now these two males means male A and male B is related only when the difference of their ages is less than 1000 is less than 1000, then clearly R2 is universal relation. Because if we have the males of a particular, it is not possible that the difference between any two males is greater than 1000 is 1000. So this means that this R2 contains each and every ordered pair from A to B. So this R2 is universal relation. So this was about these relations on set, or simply the relation on set. Inshallah, in tomorrow's lecture we will discuss the further types of the relation on set, like symmetric relation, reflexive relation, and transitive relation. So thank you.